So for number 1, we want to use the binomial theorem to write the expansion of x squared plus y raised to the third power. So something that helps me is I'm first going to label what my a and b are. I see that x squared, that's going to be my a, y is going to be my b, and n is the power I'm raising to, so that is going to be 3. So I have that x squared plus y raised to the third power is going to equal to my combination. I'm going to start with n on the left, so 3c, and I'm going to start at 0. A is going to be raised to the n power, so x squared is going to be raised to the third power, and then my b is going to be raised to the 0 power, so I'm going to have y raised to the 0 power. And I want to keep going. And so for this pattern, remember, I'm going to add 1 to my r and c. So now this is going to become 3c1 instead of 3c0. I'm going to subtract 1 from the power of a. So this is going to become x squared to the second power. So 3 minus 1 is 2. And then for my y, I'm going to add 1 to the power. So this becomes y to the first. And I'm going to keep on going until my y is raised to the third power, and I have 3c3. So next one, I'm going to add 1 more. So my 1 becomes 2. X squared, I'm going to subtract 1 from that power, so that becomes 1. And then for my y, I'm going to add 1 to that power, so it becomes 2. And then I have 3c3. X squared, subtract 1 from that power, and that becomes 0. Add 1 to the y power, and that becomes 3. So there, I'm done. I know I'm done because I have 3c3. They both match. So I'm good there. Now I just need to go ahead and simplify this. So 3c0, if you go ahead and do that combination, you should get 1. And then I have x squared cubed, so I have a power raised to the power, so I multiply those exponents, and that becomes x to the 6. Y to the 0 is just equal to 1. And you should always see this. Those on either end should always end up being equal to 1 for that first term. 3c1, when you do that combination, you should get 3. X squared to the second power, multiply those exponents, and you get x to the 4th. And this becomes y to the 1st, or just y. 3c2, when you do that combination, you should get 3. X squared to the first is just x squared, and then y squared. And then 3c3, you should get 1. X squared to the 0 power, anything to the 0 power is just 1. And then y cubed. And now multiplying that all out, I get x to the 6 plus 3x to the 4th y plus 3x squared y squared plus y cubed. Okay, let's look at one more. So here I'm going to use the binomial theorem again to write the expansion of 2p minus q to the 4th power. So something to note here in our theorem, we have a plus b. Here I have a minus sign, so that means that my a is still going to be 2p, but my b is now going to be negative q that I'm plugging in. And then 4 is my n. So expand this, I'm starting with my c, so my n is 4, and I start with 0. I have my a raised to the n power, so 2p raised to the 4th power. And then I have my b, which here is negative q, raised to the 0. Now I'm going to add and subtract where I need to. So my 4c0 now becomes 4c1. 2p, I'm going to subtract 1 from that exponent, so it becomes 3. And then negative q, I'm going to add 1 to that exponent, so it becomes 1. And then I want to keep going with that pattern. So now I have 4c2. 2p, I'm going to subtract from that exponent, become 2. Negative q, I'm going to add to that exponent, so it becomes 2. next term, I have 4c3. b raised to the first power now. And b negative q is going to be raised to the third power. And then my last term is 4c4. 2p is now raised to the 0 power. And negative q is raised to the 4th power. Now we need to go ahead and simplify all this out. So for C0, you can go ahead and actually use Desmos to answer your combination questions. And one way you can do that is if you go to desmos.com and you go to functions, you scroll all the way down, you see NPR and NCR. So NPR, that's your permutation, NCR is your combination. So if you do that, you can put here, and then you're just going to write in order the numbers you see. So here it's 4 and 0. So I'm going to do 4, comma, 0, and that tells me that that is equal to 1. 2p raised to the 4th power, I'm going to have to do 2 to the 4th power and p to the 4th power. So 2 to the 4th power, that is 16, and then p to the 4th. Negative q to the 0 power is just 1. And then 4c1, that is 4. 2p raised to the 3rd power, so I have 2 cubed, which is 8. And then p cubed. Negative q to the 1st power is just negative q. And then 4c2, I get 6. 2p squared, 2 squared, I get 4. And then p squared. And then negative q squared, I get a positive q squared. Because negative q times negative q gets me a positive q. Then 4c3, I get 4. 2p to the 1st power is just 2p. Negative q cubed is negative q cubed. And then 4c4, that's just 1. 2p raised to the 0 power is 1. Negative q raised to the 4th power is q to the 4th. And then I just need to simplify. And so make this back to full screen. I get 16p to the 4th plus 4 times 8 is 32. I'm going to have a minus sign here. So I have minus 32p cubed q plus 6 times 4 is 24p squared q squared. Minus 4 times 2 is 8p cubed, and then plus q to the 4th.